Alright, so for lesson number 3, I am asking you to do these mentally without a calculator. We should have the know-how to do this. I might write down what's happening in my head for this, but you need to be able to do what's going on here. So let's start with A up here. They have 2 times something equals 10. So I think that should be mental, but what's going on in your head here is you're just cutting 10 in half. 10 divided by 2, since they're multiplying, is the opposite. So that's how I'm getting 5 for my answer there on part A. Part B, they have a -3 times something equals 21. So they add a little layer of difficulty to this with the negative, but it's still the same idea. My thought process for this one, what goes on in my head, is my times fact that I need this to be where that comes out positive, right? And for that to come out positive, this division comes out negative. And a -7 times a -3 would be positive 21. So that makes sense to me. All right, let's look at C. If we're doing C in our head, all right, this is the one that many of you struggled on last week's quiz. How do I handle this fraction? Oh no. Well, this is what your head should be thinking. Okay, they're multiplying by a fraction. I don't like the fraction. I can get rid of it by flipping it and multiplying the other number by it. So 6, the other number, multiplied by 1/3's reciprocal, which is just the same as the number 3. That's how we get 18 for this answer. We should be able to do that in our head after knowing that trick. Alright, D is similar, just got a negative involved, alright, but it's the same idea. The number that you want to multiply by here is -1/2 flipped. So in my head, I'm thinking -7 times -2, which gives me a positive 14, and is also the answer to that problem. Alright, so that's how I'm doing these in my head. I know I wrote them out, but you don't have to write those kind of problems out in your head. That's just what it turns out to look like when you're done with it. Alright, let's move on and draw some tape diagrams. Alright, for each equation. So drawing a tape diagram for this one, let's go ahead and draw the model for it. We know that we have a rectangular bar, and that bar will have a bracket that indicates the total. Alright, and I'll draw my other one in a different color below. Alright, so this one's going to be the same idea, but this will represent B. Alright, so this is B, and the top one up here is A. So let's look at A. We have a total for 20 for both of them, so I'll go ahead and put 20 up here. And it says we have 5 x plus 1s. Okay, so we have 5 groups of x plus 1. So we need to split this up into 1, 2, 3, 4, 5 equal sections, and every one of those are x plus 1. So that's what that looks like. We have 5 times x plus 1s. So we have 5 sets of x plus 1. That's what that tape diagram would look like. Now this one is different because we don't have 5 x plus 1s. We have 5 x's and then an additional 1 added on at the end. So this one actually has 6 boxes, but they're not all the same size. Okay, let's make the 1s over here the 1. You got 1 added on. You still got a total of 20. And then you also have 5 x's that are just the same size. So let's break this up into the same size. 1, 2, 3, 4, 5, and all of these are the same size, x. Now I didn't mean for my x's to be similar in size to the 1. I don't know what their size is off the top of my head, but I know that there's 5 equal ones, and adding 1 to it gives me a total of 20. That's what this one is saying. This one is totally different. 5 groups of x plus 1. Different problem, different solution. Okay? It does not say to solve it. So you don't have to tell me what x equals. You just have to draw a tape diagram that matches the equation given. And that's what we have done.